So one place that a normal distribution has been applied is with IQ testing, intelligence quotient testing. And there's all kinds of statistical stuff going on here that's beyond what we're going to talk about. So please bear with me on that. But in terms of what I want you to know about normal distributions and how we apply them, this is the main thing. Are you ready? Here we go. So this is a website. I don't have anything to do with it. I don't know anything about it except I've used it as a tool to help us do some IQ testing stuff. In fact, you can even go and take an IQ test from this site. It doesn't cost anything, just something to do, and you can see where you fall on the IQ test if you believe in all of this stuff. Anyway, I'm not sanctioning it. I'm just saying it's a website that you could do that kind of a thing if you wanted. But here's the math that is accurate. So IQ tests are normally distributed because not that many people score low, not that many people score really high. Most people score somewhere in the middle. And so the distribution, the shape, if you were to plot this out, the shape of the number of people scoring the different scores would have that nice normal distribution, as we say, bell curve shape. This is where the statistics gets beyond what we're going to talk about, but they kind of forced it so that the average score will be 100 and the standard deviation will be 15. So notice here's the mean of 100 right in the middle. And then one standard deviation over is a score of 115. Another 15 points or two standard deviations would be 130. Three standard deviations would be 145, or back up one standard deviation to 85, another to 70, and another to 55. So this is how we would use it to compare. So here's how it might work. Suppose you took the IQ test and you scored a 115. Here's some things you could do. You could ask yourself, well, where do I fall compared to the rest of all the bazillions of people who have taken an IQ test? Where does a 115 fall? Well, that's where the empirical rule comes in. So here you are at 115. 34 plus 34, about 68. So 81, about 83, 84. About 84% of the people who took the IQ test scored below 115. And about 13, 15, 16, about 16% scored above 115. So now you know, if you scored a 115, you would have a higher score than about 84% of the people, and you'd have a lower score than about 16% of the people. That's how this normal distribution is used, as a comparison, as a tool to kind of find out what the percentage is. Or you could say something like this. Suppose you're thinking about that score of 115. What's the probability that somebody would score 115 or lower? Well, since 84% of the people score 115 or lower, you would say if you randomly picked a person, that is part of this IQ testing, that they're 84% of the time, you're going to pick somebody who's 115 or lower. 16% of the time, you're going to pick somebody who's 115 or higher. So that's kind of how this works. Now, there's a tool I'd like you to be aware of, and you'll see it linked in Canvas. But this is a tool to help us determine these kinds of percentages very precisely. So in the case of the IQ test, the mean score was 100. The standard deviation was 15. Now, remember I was doing the score of 115, and I said, well, what percentage of the people scored below your score of 115? Well, there it is. 0.84, 84%, as we kind of estimated. Or what percentage of the people score above 115? And there it is, about 16%, as we estimated previously. But with this tool, we can now get a visual and a computation for any percentage that you like. For instance, suppose you're wondering, I don't know why, but you're wondering, well, what percentage of the people score between 100 and 115? Well, then you could say, how about between 100 and 115? And so it's showing you that slice of the bell curve So between 100 and 115 is about 34% of the people. It's just the empirical rule. That's exactly what we know the empirical rule to be. 34 on either side, total of 68. Remember the first 68%. But you can use this tool for anything. Like you want to, somebody says to you, yeah, I took an IQ test online. I scored a 150. 150, huh? Well, what's the percentage of people that would score 150 or above? 0.0004 as a percentage, that would be 0.04%. So you could think, man, that means only practically nobody, 0.04%, practically nobody would score above a 150 on an IQ test. Or just any number you like. Maybe instead of a nice 100 or 150 or 130, maybe you take the IQ test and you scored a 108. And you want to know, like, how do I fare compared to the rest of the world on this IQ test? So a 108, about 70%, 0.703, so about 70% of the people score 108 or below. And which means about 30%, let's see, about 30% would score 108 or above. So you you could find out where you fall. 70% are below, 30% are above you. You know, we do this kind of a thing all the time. If you can remember, if you have children, we take our kids to the doctor and they'll say something like, well, the child's height is in the 90th percentile. Well, they're doing something like this. They're saying they have a normal distribution and they're saying, okay, your child weighs 37 pounds. And where does 37 pounds fall on this thing? You know, well, it's 90th percentile means that 37 pounds is greater than 90% of the other kids according to the normal distribution. So we do this kind of a thing all the time as we do comparisons. We want to know where we stand. In education, we do it all the time too, because we do test scores, which is what you're going to be doing in a upcoming assignment. We do test scores and we say we're in the 90th percentile, we're in the 50th percentile, or unfortunately, you know, there's going to be some, not unfortunately, just because it has to be, some, you don't have a normal distribution if you don't have the lower side, and so somebody's going to be on the lower percentage. You know, somebody's going to score a 65. So a 65 would be like, that's really low. So like 0.9, almost 1%. About 1% of the people score below 65. And so it just gives you a way to think, compare, and reason. So you will have this link in some upcoming assignments, and you will have an opportunity to practice answering questions about different situations and normal distributions and how we can use this tool to calculate things. Go give it a shot.